Okay, good morning all, or good evening, or whatever time of day it is. This is the June 2010 revision paper. This is the non-calculator portion, which is multiple choice based. So let's start having a look at what the answers are for these questions. Okay, question 1. What is the number 70560 in words? So it's always useful to put a little thousand separate in there. And then you can clearly see that's 70,560. So we're looking for 70, so it's going to be one of those two, 70,560. So it's that one there. It's the answer C, 70,560. Question 2. What temperature is shown on this thermometer? So we can see from 30 to 40 there are 5 little sections. That must mean each one is worth 2. So this one is going to be D, 32 degrees Celsius. Question 3. What is the number 87942 rounded to the nearest thousand? So in terms of tackling a question like this, there's our units, our tens, our hundreds, and there's our thousands. So we can draw a line to the right of our thousands column, and then we have a look at what digits get what's in there. So we're looking at the hundreds there. That is a 9, so that's going to round upwards. That must mean that the nearest thousand that this number is close to is going to be 88,000, because effectively what you're asking when you're rounding to the nearest thousand is which multiple of thousand is that number closest to. And it's actually, if you were to draw these on a number line, it would be right up here somewhere, because it's 87,942. Okay, halfway on that number line, incidentally, would be 87,500. It only has to be that number or above to round to 88,000. Question 4. One number is not a factor of 24. Which number? You might know this off by heart straight away, but another easy thing you could do in terms of exam prep is draw your little factor bug. I have no idea why I've written 25. 24, and you start pinging your legs off starting from 1 and the number itself. So 1 times 24 is 24. Does 2 go into it? Yes, it's an even number. 2 lots of 12. 2 and 24. I then ask, does 3 go into it? Yes. From my tables knowledge, 8 times. Does 4 go into it? 4 times 6 is 24. And we can basically see the only number between the 4 and the 6 is a 5, and we know the 5 doesn't go into it. All we've got to do now is look at which of these numbers is not in this list. So the number that isn't a factor of 24 is E, 16. Question 5. The diagram shows a shaded shape on a centimetre grid. Work out the perimeter of the shaded shape. Remind yourself when you see area and perimeter that P-E-R-I-M-E-T-E-R. The word perimeter can be written around the word area because it's a longer word, and that's a great little way of remembering what perimeter is and what area is. Area is the space inside, perimeter goes around the edge. Okay, so what is the perimeter of the shape? This is how you should do it on any such question. Mark the points off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. There you go, nearly forgot one. Okay, A, 20 centimetres. It's important you do the little marker points there so that you don't accidentally forget any of the portions of the edge. Okay, so especially if there's any of the questions where it's on centimetres, square grid like that. Question 6. Here are the first 5 terms of the sequence. Just to help us familiarise ourselves with the vocabulary, this is term 1, term 2, term 3, term 4, and term 5. The 6th term would be whichever comes next after that. So that we're being asked, what is the 6th term? So the next term of the sequence is, what we need to keep an eye on is what's going on each time. Is there a common difference? If you're not sure if there's a common difference or not, and you're not sure about working with the negative numbers, start with the positive numbers. To go from 3 to 8 is 5. To go from 8 to 13 is also 5, plus 5. To go from 13 to 18 is also plus 5. That must mean I'm adding 5 again, and that will get me 23. That's the next term in the sequence. And you can also check the negative numbers to make sure that's right. If a temperature was -2 and it increased by 5, it would go to 3. So that's what I would recommend doing on any sequences question. Mark on, like I've done in red, the common differences, or any of the differences to help you see the pattern. 7. One of the marked angles is an obtuse angle. Which angle? Okay, this is going to come down to general knowledge in an exam situation. You've got a few different angle types. You've got acute, obtuse, and reflex, as well as a right angle and a straight line. The acute angles are less than 90, obtuse angles are between 90 and 180, and reflex angles are greater than 180. So we're looking for something that is greater than 90, so not that one because that's 90 exactly, and less than 180 and less than a straight line. That's an acute angle, so it's not that one. That's greater than 180, that's a reflex, as is that one, so that leaves us with C. Somewhere between a right angle and a straight line. Question 8. What are the coordinates of point P? Along the corridor, up the stairs. So 2 across, 4 up. E is our answer to that one. We'll move on quite quickly from that. Question 9. Which shape has diagonals that must cross at right angles? Now, when we're talking about diagonals, we're talking about lines that connect any two vertices on a shape that are not adjacent to each other. What do I mean by that? If I draw a rectangle, the diagonals of a rectangle would be there and there. If I was to draw a parallelogram, which is like a knocked over rectangle, looks something like that, the diagonals of this shape would look something like that. Okay? So effectively, I'm going through each of these and we're being asked to see which of these purple lines cross at right angles. None of these are crossing at right angles. So you can see in here, this cross point, this angle that this is crossing at is not 90 degrees. It's a kind of a lot smaller than that, or a lot bigger, whichever way you look at it. So we're just going to go through each one here to check. We're going to make an effort with this one. So it's not a rectangle, not a parallelogram. Okay, our next shape is a rhombus, which is like a knocked over square. So all these sides are the same length. If I draw that through there like that, what you can see here is that if you tilt your head, this is kind of like a diamond on a playing card, and in essence, these little angles inside there will be right angles. So we're after rhombus C. That has diagonals that cross at right angles. A trapezium, it can't be this because there's actually more than one type of trapezium. You could have an isosceles trapezium, like that with a line of reflection down the middle. We could have a right angle trapezium. And a quadrilateral is basically any of these shapes at all. All of those shapes are quadrilaterals. So quadrilateral is just any four-sided shape. Okay, question 10. Which is the smallest number? I always find these questions can be misleading because the vocabulary in the question is poor. It probably means which is the lowest number, because the smallest number can be defined as like the magnitude of or the size of a number. I would likely assume that it's really meaning the lowest number. In that instance would be -6. If it's the smallest number in terms of magnitude or size, then technically that would be 0, because it has no, the number itself has no size, it has no worth. But I think this is a poorly written question, and what it's asking is lowest. Okay, the lowest number would be -6. In terms of temperature, that's what would be coldest. Question 11. Jane's age is n years. Duncan is 5 years younger than Jane. What is Duncan's age? Okay, these expression type questions often get people in a pickle. The best way to do this is actually to do a couple of little practice examples. For example, Jane's age is 7. I just made that up off the top of my head. Duncan is 5 years younger than Jane, so Duncan would be 2. So if we made a quick little table here, J for Jane, D for Duncan, when she's 7, Duncan is 2. When she is 10, Duncan is 5 years younger than Jane, so it would be 5. When Jane is 40, Duncan would be 35. Okay, so there's just some little examples. What is Duncan's age? So we need to find an expression that connects these two things together. Jane's age is n years. So that value there, we can just use the letter n. Duncan is going to be 5 less than that. So what are we doing to go from 7 to 2, 10 to 5, 40 to 35? Well, each time we're taking away 5. So we're looking for n, take away 5. If you weren't sure about this, then you could actually substitute in a value for each of these and see what happens. So if we imagine that Jane was 3 years old, then in this instance, Duncan's age here would be 15. 5 times 3. If it was this way round, it would be 5 take away 3. Duncan would be 2 when Jane is 5. But we know that's not right because Duncan is 5 years younger than Jane. In this instance, it'd only be 3 years younger. We know it's not C because then you'd be saying 3 plus 5. So Duncan would be 8. And it can't be D because, well, there's no n value involved. And there needs to be some n value because that's what Jane's age is there. So that hopefully that explains a little bit why the answer is E, but also why the answer aren't any of the other ones. Okay, question 12. Here's a rectangle. What is the area of the rectangle? Area is width times length. So here it's going to be 15 times 10. Let's not mess around with that one. 150 centimeters squared. We'll move on to the next one. Question 13. Which is the largest number? Okay, so in this instance here, when we're saying largest, now that there's no negatives, unlike the previous question, we're just assuming which is the greatest value. Sometimes these people misread these and they see the word largest meaning which has got the most digits in it, and some people would be potentially rush to answer that one there. What we're effectively asking here is which of these numbers is greatest. If these numbers represented the amount of gold you had, which would you want? What is the largest one? Which is the largest number? I tend to recommend to people writing every single number stacked above each other like this, so you can really compare the place values. This particular question is actually, in my opinion, quite an easy one, but you could easily make mistakes on this. So these are the 4 numbers written out. Done it again. I've written a 5 instead of a 4 for some reason. Written out in terms of accurate place value places. Now they've got different numbers of places, so we're just going to fill in with zeros such that every single one of them has the same number of zeros. We can do this after digits, significant digits, or any digits and decimals. It's not changing the number at all. It's just basically allowing us to make it easier to compare them. I can kind of imagine the decimal to not be there and see the first one is 6,000, the next one is 6,040, the third one is 6,400, and that one there is in fact the largest number. So that is our answer to this question. But only when we see these numbers stacked does it become a little bit clearer. This is the sort of thing you can do in an exam to avoid giving away a silly mark. Okay, question 14. PQR is a straight line. That's from there to there. QST is an equilateral triangle. I'll do a bit of colour coding. So QST goes from there to there, down to there. Is an equilateral triangle. Angle SQP is 72. So we are talking about from S to Q to P. So we're talking about that angle inside there, 72. So it's already given to you on the diagram. What is the size of the angle marked X? So you've got to try and find that angle there. What do we know already? Well, angles on a straight line add up to 180. We also know that all the angles inside a triangle add up to 180. What we've got here is an equilateral triangle. We've been told that in the words. So what we do know, even though we've not been given anything on the diagram, that every single one of those angles are identical to each other because it's an equilateral triangle. And therefore every single one of those is going to be 60, as 3 lots of 60 is 180. So I can just write a little 60 in here. In an exam, I would strongly encourage you to label everything you can on a diagram to fill in all the gaps, because that normally ends up giving you the answer. What we can see here is the problem we're now faced with is a straight line problem, whereby we have 72 plus 60, and then the x is our unknown value. So 72 plus 60, which is that part, is going to be 132 degrees. We would then have to do 180, take away 132, leaving us with 48 degrees. So the answer is B there, so 48 degrees. We know we've done this right if we add the 48. Little check you can do afterwards, maybe you've got a spare bit of time. 48 plus 60 plus 72. In theory, that should add up to 180. 8 plus 2 is 10, so the 1 is carried. 4 plus 6 is 10, plus the 7 is 17, plus the 1 that's carried, 180. So I've double checked my work with my spare time that I've got by adding up and performing an inverse calculation. Question 15. Mr. Akbar left home at 8:35 to go to work. He arrived at work at 9:17. How many minutes did it take Mr. Akbar to get to work? With time questions, totally up to you, but I'm going to show you how to do this on a number line. 8:35, 9:17. And I'm going to show you on a number line purely because people make silly mistakes with time. They add up to 100 rather than adding up to 60. Going to go super basic here. 5 minutes takes us to 8:40. 20 minutes takes us to 9. And then a further 17 minutes from there takes us to 9:17. What I now need to do is add up the 5, the 20 and the 17, which is going to give me a 2 there. That's going to give me 12 with the 1 carried, and that's going to give me 42 there. 42 minutes D. Okay, so it's basically 25 minutes gets you to 9 o'clock, and then a further 17 minutes gets you to 9:17. It's very easy to get this right. It's very easy to get it wrong. The number line should help you to calculate time difference as well by breaking it into small sections. Question 16. 12 plus 8 times 2 take away 1. I've always recommended to my classes that you number the order of the operations, and you see something with more than one calculation going on, bid mass. Let's remember the order. What do we see? I see a multiply, I see an add, and I see a subtract. I'm going to do the multiply first, and then the add and subtract, you have technically do these in the order in which they're written. So they're jointly together, side by side, and then you follow the order. So it would then be this one and then that one. So I'm going to do 12 plus 16, take away 1, because I've done my 8 times 2. I'm going to add these first two parts together to get 28 minus 1, which will then give us 27, which is A. Question 17. Here are the first 4 terms of the sequence. Another sequences question. Last time, as I advised, find the common difference, or find the difference each time, see what's going on. 1 to 7 plus 6, 7 to 13 plus 6, 13 to 19 plus 6. Okay, so each time we're going to be adding 6 and so on and so on. One of these numbers is a term in a sequence. Which number is it? So in this instance here, there's 2 ways of doing this. You can either sit there and count on in 6s until you get there, or you can recognize that this is basically the 6 times table with an adjustment. So with this being n, 1, 2, 3, 4, the first, second, third, fourth term, what we're saying is, if this is going up in 6s, then it's going to be 6n. What do we have to do for 6n normally? Well, we would write out simply like this. All right, well, that's basically the 6 times table. So that's going to be 6, 12, 18, 24. But what we've got going on here is 1, 7, 13, 19. So what we have to do is kind of what's going on each time, how we're adjusting to get from there to there. And what you can see each time is that you're taking away 5. So our rule is 6n take away 5, and that will find you any number in the sequence at all. To check if any of these numbers are in the sequence, you could sit there and go, all right, well, what will happen if I do 6n take away 5 equals 45? Will I be able to solve that? Will I be able to solve the next one? And so on and so on. If I'm honest in this sort of question, I would just keep adding 6s each time. I think you would have more success with that quicker. Another 6 added on to 19 would be 25, 31, 37, 43, 49. That's probably the quicker way on this sort of a question. You don't, I think it'd be wasted time to actually sit there, come up with a sequence and then solve it as an equation. Just counting on would probably be far easier. If these numbers were much larger, like in the hundreds or thousands, then you would probably need to go down an algebraic method. Question 18. N is an odd number. One of these expressions always represents an even number. Which expression? Okay, so we're understanding what it means to be odd and even in terms of algebra here. One of these expressions represents an even number. So we're being told here that the n is an odd number. So why don't we put an odd number in for n and just play around with it? So one of these expressions we're told always represents an even number. So what happens when we put n equals 3 into this one? Well, this is going to end up being worth 5. Is that an even number? No. Okay, let's try the next one. N is an odd number. So if we take n equals 3, as we've done here, 2 times 3 plus 1. That's going to give us 6 plus 1 equals 7. Is that an even number? No. Let's try the next one. 2 times 3, take away 1. That's going to give us 6 take away 1 equals 5. Is 5 an even number? No, it isn't. And by the way, just to remind you, where have I got the 3 from? I just picked any odd number because we're told that n is an odd number. So pick a nice easy one to work with and substitute it into each one. All right, let's try another one. N is 3 plus 1. Will that give me an even number? Yes, it will do. I'm not going to tick that just yet. I'm going to check the last one as well. what I've got here is 3 times 3. And that in this instance, that's going to give me an odd number. Now the only one so far that hasn't given us an odd number is this even one here. If I had time, I would also check it with a couple of other ones as well. Maybe I'll check a different odd number, 5 plus 1. Will that equal 6? So that will also give us an even number as well. And remember, an even number is basically any number that when divided by 2 has no remainder. An odd number is any number that when divided by 2 does have a remainder of some sort of leftover. Question 19. Here is a right angled triangle. What is the area of the triangle? The area of a triangle is base times height, all divided by 2. Or it can also be written as a half times base times height. Where does that come from? Very similar to that of a rectangle. It's going to be 6 times 4, which will give us this rectangular area. Then we'd have to half that to find out the triangle area. That's going to give us 24 over 2, which gives us 12 centimetres squared. So the answer to that is A. Question 20. -8 take away -5. There's 0. There's -8. If I'm subtracting something, then
I found this on the web.
Go away, Siri. If I'm subtracting something, then I'm going to go in this direction, further away from 0. So I'm going to be taking away 5 from that. So we're looking for numbers that are going to be lower than -8. In fact, the only one it can be is -13. -3 is going to be in there somewhere. Number 3 itself is going to be there. 40, I don't know why someone will get 40. They'd have to totally misread and mess up the whole question. And 13 is going to be somewhere over here. Okay, so answer is -13. Question 21. T is the point 64. M is the point 43. And M is also the midpoint. Which are the coordinates of the point S? Oh, this is a nice question. I like this one. Okay, so what we're doing here is we want to find out how far away on the x-axis it is, the difference of x, and also the difference of y. If it's the midpoint, then it's going to be completely the same as it is from there to there. As it is from S to M, it will be the same as it is from M to T. So to go from M to T, just write these above one another, we can see that the x value we're having to add 2. The difference between these two values is 2. The difference in the y values is 1. Okay? What we would then need to do is take this this difference off from M, and that will allow us to find what S is. So, with that being said, M is 43, that's our midpoint. And what we're going to do is we're going to subtract 2, 1 from that to find out what S is. So 4 take away 2 is 2, and 3 take away 1 is also 2. So we would be looking for the answer B. Okay, so just to recap on that one, the midpoint we already know. What we've tried to do here, what we've found here, what we have found there is the difference. That is 2 along and 1 up. 2 along and 1 up. So hopefully me labelling that on there can help you to see how far are we going from M to T. crossways and upwards, or along the corridor up the stairs, along the x-axis, up the y-axis. It will, because it's the midpoint, it will be completely the same going from M to T as it is from S to M. If you do have any questions about that, please ask your teacher. Okay, question 22. Bearing in mind this is a non-calculator, this needn't be as hard as we think. Remember that fractions are division. The numerator divided by denominator is just division. How many 8s into 24? It's going to go 3 times, and there is going to be 3 left over. So we're going to be looking for basically an answer of 3 and something. So it can't be that one, can't be that one, and it can't be that one. Immediately we've ruled out 3 questions. So it goes into it 3 times. Now, when you perform a division question using bus stop, bus shelter, whatever you want to call it, and you get that little remainder, that remainder actually is the numerator, becomes the numerator, and the denominator would be the divisor. In other words, the amount you divided by, 3 and 3/8. Another more visual way of looking at this is how many whole ones make up 27/8. So there's 8/8 plus 8/8. So that represents 1. That represents 2. If I add another one, that represents 3 whole pieces. So that's 8/8, 8/8, 16/8, 24/8. How many more 8s have I got to get up to 27/8? That would be 3/8. Altogether there, I then have 27/8, which was our original question. What you can then see from here is you've got 3 whole ones and a remainder portion left over. Okay, question 23, nearly there. The highest common factor HCF of 24 and 40 is... Okay, which one of these? Get this the right way around. Factors are numbers that go into things. Okay, they're not lots of, they're things that go into things. So we're looking for a number that goes into 24 and 40. So it's definitely not going to be a bigger number. Automatically, we've made it a best of 3. Or a 33% chance of just completely guessing, as long as you remember what the word factor is. Factors go into numbers. So does 2 go into both of these numbers? It does, because they're both even. A quick check in our heads. 4 times 6 is 24, so that goes into 24. It also goes into 40. Fine. What about 8? 8 goes into 24 3 times. And it also goes into 40 5 times. So that just comes down to knowing tables. So the largest number that goes into both of them, the highest common factor, is 8. Question 24. 36.8 times 1.65 equals 60.72. So we're given that as a fact. You don't need to think about that. You're just told that. The value of 3.68 times 165 is what? So this comes down to our reasoning and understanding of the number system. I'm going to write this fact out. And I'm going to make a series of adjustments, which hopefully should make sense as to why I'm doing them and lead us to what the question is. There are 2 ways of approaching this. I'm going to approach this in 2 different ways. One a very numerical method and one that's very estimate based. Okay, so if I then make this number, this first number 10 times smaller and leave the 1.65, that's going to make the answer become 10 times smaller. Okay, I've now got that one the same. I'm now going to adjust the 1.65 such that it's the same size as this one. So I'm going to keep this the same now. I'm going to make this number, the second one, 10 times bigger. So that's now going to become 16.5. If I make one value 10 times bigger, the answer is going to be 10 times bigger. So we're kind of back where we started. Next, I'm going to keep this number the same. I'm going to make this number 10 times bigger again, 165. That means my answer is going to be 10 times bigger again. going from 60.72 to 607.2, which the answer is C. Before we move on to the final question, I'm just going to talk through another way of thinking about this, which might be quicker for some of you, might get this. This number is roughly 4, and this number is, what's it close to? It's between 150 and 200. So we're looking for a number that's between that and that. So I'm just using some estimate checking. 4 lots of 150 is 600. 4 lots of 200 is 800. So we're looking for a number that is 3 digits in size, which rules out that one, that one, that one, and that one. So you can kind of get there by ruling out all the others with good quality estimate checking. Okay, final question. Here are the first 5 terms of an arithmetic sequence. This basically means it's going to be going up with a common difference each time, and that will be, or going down with a common difference each time. So it could go up, it could go down, it could increase, or it could decrease, or ascending or descending. They're the words that we use. Let's double check this one. I think we've seen this one before earlier. It's going up in 5s each time. So we're going to be looking for something that's got 5n, because when it's going up in 5s, we're basically saying this is like the 5 times table but adjusted. So how many of these can we see of 5n? Well, I can see this one, and this one. The other 2 I can automatically cross out. There is no lots of 5. The most common mistake is that one, because students see it adding 5 each time. They see the add 5 and then they think it's that straight away. This is actually going up in 5s each time, so it's going to be like the 5 times table. What does the 5 times table look like? Well, 5n on its own, which is this one, looks like this. 5, 10, 15, 20, 25. What does the sequence we're given look like? Okay, the first expression is -2, 3, 8, 13, 18. So what we want to be having a look at here is, what adjustment do we have to make to find out this mysterious rule going on here? So what do I have to do to go from 10 to 3? Take away 7. What about from 15 to 8? Take away 7. What about from 20 to 13? Take away 7. From 5 to -2, take away 7. Probably becoming a bit obvious now, take away 7. So basically, our rule here is 5n take away 7, because it's basically the 5 times table with 7 taken away from it each time. And I am aware of how many times I say basically every other sentence. Basically, I can't help it, but basically that is the end of this paper. There will be a link linking on to the next one, the main questions, but these are all the multiple choice ones for now. Any questions, please ask your teacher.